My talk is going to be about native assets, which are an in development and sort of upcoming feature that will be part of sort of the next Dart and Flutter releases. And they will make it a lot easier to sort of, if you're building a cross-platform FFI plugin that talks like a native library in your Dart application, that will make it the whole process a lot easier. But I should mention before I sort of introduce myself and why this is such an exciting topic to talk about, that this feature is still in development. And in fact, since the time that I've submitted this talk, it has actually been renamed to just code assets. So it's no longer called native assets, it's just called code assets. That's actually a really exciting thing because it means that it will work on all Flutter platforms in the future, including web. But the talk that I'm going to give today is mostly centered around doing that work on like native, so mobile and desktop operating systems. So hi, my name is Simon. I have done a lot of sort of Dart open source development work over the past couple of years. So something that you might know me for is the SQLite library. So if you're using the SQLite database system in your Dart application, that might be using some code that I wrote. And I've also written Drift, which is a sort of higher level database package that wraps the SQLite package and sort of makes it a lot easier for you to write your queries, gives you like reactive query streams and so on. So that's a package that I've written as well. So the main thing is that for all the work that I'm doing on the SQLite package and Drift as well, I need a pretty solid foundation. And that foundation involves all your Dart code, which is shown here on the left, talking to native libraries, or in my case, specifically SQLite on the right. So whatever I do, so all the features that I'm written for in Drift, they need these two to talk to each other as efficiently as they could possibly be, because otherwise it's all kind of pointless and we're adding unnecessary overhead. But I'm not the only one with this particular problem, so I've sort of picked some mostly random selection of other cool packages that are also binding to native code. So here in the top left corner you see Isar, which is a database system that has been half implemented in Dart and half in Rust for performance. Right next to SQLite you see PowerSync, which, full disclosure, I'm being paid to work on, and that's a sync engine that sort of syncs your SQLite database that you have in your client with whatever you have in your backend. And there we are also using a Rust component as a sort of shared source. But even outside of the database space, so there's Objectbox as well, which is also partially written in C++. And there are some cool Dart bindings to other packages. So for instance, there's the Lipsodium package, which is a sort of encryption system. And there's a nice Dart package, which is sort of wrapping around that. And for those of you who are using Flutter, perhaps on a Raspberry Pi, you might want to talk to like the serial pins, and there's a cool bindings around the serial hardware interface from the Silprop project as well, right? So what all of these libraries in the end have in common, obviously, that they compile down to native machine code, right? Like that's why we're calling them native libraries. So they might be written in C, C++, or Rust, but in the end, the way that we access them is by sort of invoking the machine code that they bring down, compile down to. But as Flutter developers, I think you know that Dart will also compile down to native machine code, right? Like that's what makes a Flutter app so fast and so efficient. And so in the end, the kind of question that I'm being facing with here is, well, how do I make the machine code on the left talk to machine code on the right, right? So how in the end do I call C from Dart? And considering that this is both machine code, this should be a trivial problem. It's kind of like asking, well, how do I call a C function from C, right? And the answer is, well, I just call the function, right? Like I tell the compiler that the function is available, for instance, by either including it through a header file or explicitly marking it as extern, and then after I've done that, I can pretty much just use them, right? Like so, once I've told the compiler about everything that should be available, I can just call it in my main function in C, and I generally don't really have to worry all that much about the details of how that library is actually being made available later on, right? So I don't have any platform-specific concerns in my C code here, and I think it's very reasonable to expect that we kind of want the same behavior for Dart as well, right? So there's this whole chain of linkers and loaders and the compilers that are all platform-specific. But in this case, my C code, which invokes this like library function, is actually not depending on any platform-specific behavior. And so it's like the same main method that we have for all platforms. And so if you sort of extract these properties and why we expect them from Dart as well, I think some of the aspects are, first of all, we want this to be fast, right? Like the reason that we are using these native libraries is because they might be a little bit faster than if we had implemented them in Dart. And so if there's like a huge overhead every time that we invoke a C function from Dart, well, we're kind of missing the point, right? So I think it's very reasonable to expect that everything that we do in C, if you call it from Dart, should be sort of similar from a performance characteristic as if we had just written the original thing in C. We also want this to be portable, right? And what I mean with that is not only that it can run on all platforms, I think that's pretty much a given with Dart, is also that I shouldn't have to concern myself as an application developer or a library developer with like platform-specific things, right? Like if I'm binding to a C library from Dart, I should have to know Dart and I should have to know C, right? Like there's no reason for me to know Gradle or I don't know, like Android-specific Kotlin build scripts, right? So I think that's included in Portable. And on a similar note, I want this to be simple, right? Like there shouldn't be any mental overhead that I would have to do in Dart that I don't have to do in C, right? I think Dart is a high-level language, and so it's a pretty reasonable assumption that everything that we do in Dart should at least be as simple as it is in C. And I also want this to not get in my way, right? So I want, if the C call is synchronous, calling it from Dart should also be synchronous, right? Like it shouldn't be asynchronous for no reason. Another thing is, I don't want the C and the Dart to be like entirely independent processes that I can only talk to each other using like stuff like RPC, right? So for instance, coming back to the Libsodium example, the encryption library that I've showed before, a common thing that you might want to use is I allocate a buffer in Dart, which contains like my plain text data, and then I want to encrypt it and use like the same buffer afterwards, which should just contain the encrypted stuff at that point. And if I don't have shared memory, I would just have to do like 2 mem copies at that stage, which is super unfortunate, right? So I think we've kind of outlined the goals of what we're trying to do in Dart here. And so I'll now take you to a little bit of a history lesson towards the sort of approaches that we had for this in the past. So because before Dart FFI was a thing, we were kind of restricted in what we were able to do, and pretty much the best option we had for any kind of, if you want to access any kind of code that hasn't been written in Dart, were to use platform channels. And the way that platform channels are implemented, so I'm showing Android as an example here because it's like the worst platform for this particular use case. But the way that platform channels work is that if you create like your method channel in Dart, the way that it's implemented is that the Flutter engine, which is written in C++, obviously, somehow needs to talk to the Android specific code that you've written for your Flutter plugin, right? And because Flutter is essentially the engine in C++, and all your Android stuff is Kotlin or Java, that will invoke some JNI invocation, right? So like some Android-specific thing just to get the request that we're trying to make to Android. And then specifically, if the stuff that we're trying to call is not available as an Android library, but rather as something native, right? So for instance, if you're binding to SQLite, well, SQLite does have Android bindings, but there might be other native libraries which don't have those. And so there's another JNI invocation just to get the Android code to talk to like all your native libraries beyond that, right? And it's kind of a ridiculous amount of overhead because Flutter and your native library are both fundamentally on the same stage, right? Like they should just be able to talk to each other. And so if you look at some of the downsides of platform channels, for this specific kind of goal, if you compare the original goals and see how platform channels hold up to that, I mean, platform channels, there's been a lot of work into making them as fast as possible, and their overhead isn't terrible, but it's still an overhead that is very noticeable, especially compared to like a direct call, right? Like I would expect calling a C function from Dart to be similar as just calling a Dart function from Dart, right? So that's the kind of performance that we're aiming for, and we're not really, anywhere near that with platform channels. They're also not exactly portable because first of all, I need to write platform-specific code, right? Like I need to write like my Android bindings that implement the other half of the platform channel. I need to write something similar for iOS, macOS, Linux, Windows, right? So it's very much a platform-specific concern that I need to be aware of. And they're also Flutter only, right? So, I mean, I know that this is a Flutter conference, but this is still something that you should care about because stuff that is Flutter only cannot be used in unit and widget tests. And I think this is super unfortunate because you have these perfectly testable libraries like SQLite or Libsodium, and they're perfectly deterministic, right? So you should just be able to use them in tests without any issues. But because they require platform channels, you just have to sort of mock them out, right? And that leads to worse tests, which is also bad, even if you only and exclusively care about Flutter. I think it's also pretty clear that it's very far away from being simple, right? Like it's a very complex translation layer. It's not synchronous because we have this kind of message passing approach between different threads, and we can't really use shared memory without an additional setup. They have added isolate support very, very recently, but it's still kind of limited because you need to pass like the root messenger token around, and so it's just not quite as easy as it's supposed to be. But of course, I think since like 4 or 5 years ago at this point, these three question marks in the beginning, at the end of the slide, have actually been implemented, and we have access to the Dart FFI system for now. And what Dart FFI is doing stands for foreign function interface, and it allows our Dart code on the left to talk to native libraries on the right directly and without any intermediate overhead. So if you're more interested in like the basic details of FFI, I think there's another talk later today about integrating native plugins, and there also is another one tomorrow. So I'll sort of skip the details here, but I will sort of, to get us all on the same page, I will show like the 4 elemental steps that we have to use to sort of talk to native libraries using FFI. So the first step is that we have to actually obtain an instance of the library that we're trying to talk to. And the API for that is called dynamiclibrary.open, and that will essentially tell the Dart runtime to load a native library in some platform-specific way. And we have to sort of specify the path of the library here, which is something that we didn't have to do in C. So in a sense, it's a bit worse than C. And even that is actually a platform-specific concern, because the path that we're providing here, so for instance, this dylib, that's actually macOS specific, right? So on Linux, it would be an SO, and on Windows, you would have your DLL. So that's already a bit of a platform-specific concern here. And then afterwards, after we've loaded the library, it's pretty straightforward, because at that point, we can sort of look up functions or C fields by their name. And after we've looked them up dynamically, the next step is to convert them into something that we're able to use from Dart, right? So this is the kind of translation layer that I'm aiming for here, where we have this uppercase int on the one hand, and the reason that we sort of have to specify this type twice is that C has multiple integer types and like different bit width, but Dart only has a single integer type, which is 64-bit, and so we have to provide that additional information that the runtime can't really figure out without us. So that's like the sort of duplicate type signature at that point. But once we've converted them to Dart, it's actually incredibly easy to call them, right? So if we have a function, we just call the function. And if we have a field, we can use .value, which has a getter and a setter, which we're able to use. So I think Dart FFI is already a massive improvement over what we've seen with platform channels, but we're not quite there yet. So we're seeing that the overhead of FFI is actually way lower than what we've seen with platform channels, so that's good. They're also supported by all native platforms, and we've seen a little bit of platform-specific code related to how we load the library. But after we've done that, the way that we're using the library is actually the same on all platforms, right? So this is also a massive improvement. I still wouldn't call it quite simple, right? Like we've seen the original C snippet where we're just declaring the functions and then we're able to use them. And there's still a lot of additional stuff that we have to do for FFI. But the sort of last 2 goals about it not getting in the way. So it's perfectly synchronous, and we have shared memory between everything in Dart and everything in C. So that's a good improvement there. And now, next, I kind of want to highlight the critical step of how we can actually obtain the library that we're trying to bind to. So we've seen that we can access the methods from our native libraries after we've loaded them to Dart, right? Like after we sort of have them available, we can sort of look up all your functions, and we can load libraries, but that assumes that they're available to the app at runtime, right? Like in some way, the operating system needs to be able to provide the native library that we care about to our Dart or Flutter application. And the big downside is that we cannot actually force the operating system to do this, right? So the Dart ecosystem doesn't have like a generic way that works across all Dart runtimes that would actually enable a library to be consistently available. So there are some very platform-specific workarounds. So for instance, if you're building a server-side Dart application, that is probably going to run in a Docker container. And as a library author, you could say, okay, if you're using my library to build a Docker image, please add this apt-get install command or whatever to make sure that my package is actually going to work after you build the container. Similarly, if you're building like a CLI executable in Dart and that relies on native code, you can just perhaps have something like an install command that downloads the necessary native libraries, and then they're going to be available because you've installed them. And for Flutter, one thing that you might have seen if you're using packages that rely on native code is this kind of pattern that, I like to believe that I came up with this, but I might be sort of misremembering this. It's this kind of flutterlibs package pattern. So if you're using SQLite on Flutter and you don't have like a higher level package that depends on this package for you, the way you ensure that SQLite is available to your Flutter app is you depend on SQLite flutterlibs. And for some of the other packages which I've shown to you, they're using the exact same pattern, right? So if you're using ObjectBox in Flutter, you're going to depend on ObjectBox flutterlibs. If you use PowerSync in Flutter, you're also going to depend on PowerSync flutterlibs if you're not doing it through some other helper method. So this is a bit of an odd system because these are packages in the sense that they are published to pub.dev, but they're not packages in the sense that they would contain Dart code, right? Like they literally have no API. There's like an empty lib folder or like some stuff in there, but that's just dummy stuff, right? Like there's nothing in there that is inherently providing you an API to use in your Flutter app. The only thing that they really do is they register themselves as a Flutter plugin, because once you are registering your package as a Flutter plugin, you get to write platform-specific code, right? So for instance, I could have like a Gradle build script that has an NDK declaration that ensures that SQLite gets linked with the application if anything depends on my library. Similarly, we have other options. So with SwiftVM, I can also bundle native C code, and that ensures that all sort of Apple platforms that depend on my library can actually have the libraries available, so the native libraries available. On Linux and Windows, we can use CMake, which makes this a bit easier. And CocoaPod's also mentioning that one. But we should probably migrate to SwiftVM at this point. So this works really well. And so for Flutter, this is essentially a solved problem. But I would say that the solution is not quite as good as it could be. Because first of all, this is another package to depend on. We're all sort of trying to get control over our dependencies. So it's not great. Like most people don't really enjoy adding new dependencies. And another downside is because it's a Flutter plugin, it's not going to be available in your unit tests, right? So again, the whole thing that we were trying to solve about making this available to all Dart platforms, we can't really do it because this way of making the library available is not going to work in like unit or widget tests. So if you sort of compare what kind of upsides we've gotten from Dart FFI, I think we might have to retract the statement about Dart FFI being portable, because yes, it runs on all Dart platforms, but it still leaves a lot of platform-specific as the application or library developer, right? So it's not quite there yet. So with that said, I now get to talk about maybe my favorite feature that is kind of upcoming or currently in development, and that is code assets. So to sort of sell you on code assets, I think I first want to show you a snippet that is sort of a re-implementation of the sort of example where we bind to an external library in Dart. And so this is how that would look like if we're using code assets. And I think, maybe I'm the only one here, I hope I'm not, but I just love this, right? I think this is just so neat because pretty much all of the additional overhead that we had with the old style Dart FFI system, that's just entirely gone. So if you look at the original C code as a sort of reference there, I think we have the kind of mental overhead down to the absolute bare minimum that would even be possible in Dart, right? So yes, we have to import Dart FFI, and yes, we have to add this kind of native annotation there because still C has more integer types than Dart, and so we sort of have to spell it out twice. But apart from that, I mean, it's literally the main method is exactly the same thing, right? Except that we have like type inference in Dart, right? So I think that's really, really neat. And so something that we specifically didn't have to do or don't have to do anymore is loading the library, right? Like, so just the way it is in C, we're sort of pushing the responsibility of making the library available to the operating system, to the linker, to whoever's writing the sort of build methods for us, right? And so if you look at the distribution problem again, which is sort of centered around how we can actually make SQLite or all the other native libraries available, this isn't just a syntax change, right? Like this isn't just some magic thing where the compiler sees these add native annotations and it turns it into whatever we would have written with FFI regularly. This is actually implemented in such a way that during all parts of the Dart compilation process, every kind of compiler that is part of that will know which native functions have been called, right? So this doesn't just get thrown out. And because we're no longer looking up symbols by their name at runtime, we're kind of looking them up at compile time because we are forced to sort of name our Dart methods or give them the same name as our C methods. And so all parts of the compilation process are aware of all native methods being called. And this will enable some really cool things in the future. So for instance, one thing that we would be able to do is to link libraries statically, right? So instead of having the Dart runtime load our libraries at runtime or us having to do that, we would just be able to say, if you run like Dart compile exe or just Flutter run, there's going to be like a single sort of binary output generated by those, and that could just link all our dependencies statically, which would be really nice. And another thing that we would be able to use is that the Dart compiler, if you're running like release mode apps, is going to look at like a call graph of all our functions, and then it starts at the main method and sort of throws out or never even considers methods that are never called, right? And this is quite nice because it allows us to ship libraries, and then if you depend on a library and only use like a tiny feature of it, you don't have to pay the cost of sort of adopting the entire library. But that sort of falls short with native libraries today, because there's no step in between where we can actually say, okay, we depend on SQLite, but we only use like this specific feature of it. and then we still have to pay the cost of the entire SQLite library, which, to be fair, isn't that big, but there are worse offenders. So it's still nice that we would be able to sort of use half of a native library. So another nice thing is that we didn't have to explicitly load any libraries, right? So we're pushing that responsibility away from us. So then the question is, how in the end is the library actually made available, right? Like how does it work? We don't have to do it manually anymore, but what is the automated system that replaces it? How does it look like? And that is another feature that is being added to both Dart and the Flutter SDKs, and they're called build hooks. So what a build hook is essentially a sort of standalone Dart program that runs whenever another Dart program is being compiled, right? And so I can sort of show you a bit of an example here of how build hooks are generally structured. So if you're writing a package, but this also works if you're writing an application, then you can do the same thing, is that you create a folder named hook in your package, and then inside of that you put like a build.dart file. And you import this helper package called package hooks. And since it's a regular Dart program, you have your regular main methods taking all your arguments as a list of strings. And then the build method sort of splits these arguments and provides you with a typed input and output representation of what your hook is able to do. And the responsibility of these hooks is to add the native libraries that your Flutter app is going to depend on. And the way that works in the end is that whenever you invoke any kind of tool that compiles Dart, so they could include Flutter Run if you're trying to run a Flutter app, but it could also include Flutter Test if you're running your test files, which are then sort of the main entry point of your Flutter app, right? So anytime any kind of Dart gets compiled as an application, the code asset system is going to run. And it's the responsibility of the sort of main entry point, so either the Dart development tool or the Flutter command line tool, to sort of forward. I'm simplifying things a bit here, but essentially we're forwarding the sort of target operating system and target platform to the code asset system. And the code asset system is then responsible for finding all packages that you depend on which contain a build hook. And so, for instance, let's say you are using Flutter Run to run your app on an Android emulator, then it's probably going to say, okay, please build an app with the Android as a target operating system, and we want to use 64-bit ARM as a target architecture. And that information gets forwarded to your build hooks. And because a build hook is just regular Dart code, it can do whatever it wants with that information, right? So it could find a sort of library to link from the file system. It could, sort of shell out to a C compiler and just compile it for the target platform on demand. But whatever it does, in the end, it will tell the code asset system what it did, right? So for instance, it might say, okay, here's this library which I've just created for you. And so it will have a .so ending because Android is Linux. And whenever there's a native method in foo.dart, please resolve that against this library which I've just given you. And additionally, we are able to specify inputs as files, which essentially means that if some of our non-Dart code changes, we might want to rerun some build hooks because they logically depend on it, right? So for instance, if we've compiled a library from a bunch of C sources, we probably want to do that again if their inputs change. So there's like this built-in caching system in the code asset system. But in the end, after all the build hooks have been invoked, what's going to happen is it sort of aggregates all of the results, right? So if you depend on like 10 packages providing different native libraries, it would return all of these 10 libraries. And then the tool, which you've invoked originally, that's the one that's going to be responsible for actually ensuring that these libraries are available to the system, right? And so the entire sort of array that we are accessing dynamic libraries now is now transparent to our Dart code, right? Because the Dart code just sort of specifies which methods are available, and then a whole other system is responsible for actually making these libraries available. So it's like a pretty nice separation of concerns here, and that makes the actual Dart code that we're shipping to users that is part of our app a lot more sort of cross-platform sort of aware. So these kind of libraries that we're emitting here, they're called code assets in this kind of notion. And they're just essentially just files that are cached somewhere in your .dart tool folder. So you don't really have to care about these. That will not sort of clutter up your file system. And they have an attached asset ID, which is essentially a Dart file. And then, as I've mentioned, if that Dart file contains a native annotation, that points to a C function, and that C function is going to get resolved against the code asset which I've generated. This doesn't just work for libraries, so I think for libraries it makes the most amount of sense, but I can also compile like helper scripts, for instance, as an executable that I might want to package in my Docker image or whatever I'm trying to build with Dart in the end. And they contain some instructions for the runtime, so Flutter or Dart. about what it should do with the library that I've generated. So typically that would involve bundling the native library with your app, which then ensures that it's available at runtime. And since it's created during the build process, sort of half dynamically, I have a lot of flexibility as a package author when it comes to actually defining how these look like. So I think perhaps the simplest approach is I might have some precompiled native libraries that I'm just shipping with my package, right? Like I'm just putting them in some assets folder, and I want all my apps that depend on them to just be able to use them. And that is extremely easy to do. So in my build method, that is part of the sort of hook method, the sort of build hook here, I essentially just write outputs .assets, and then it's going to be a code asset, so I write .code, and then I just add the asset. And so there's this package and the name, which points to the Dart file that should be able to use it. And I will just specify the sort of path to the file that it should be using. And finally, I tell the Dart system that it should bundle the specific library with the final application, right? And that's all I had to do, right? I didn't have to, I don't know, write any Gradle build scripts. I didn't have to write any CMake. I didn't have to write any SwiftPM code. Like all of the stuff that I fundamentally shouldn't have to know, that has been delegated to the Dart or Flutter tool that is building the app in the end, right? So that's what I think makes it so amazing. And perhaps as an additional source of inspiration, I just want to sort of quickly show you some of the very cool things that can be done with build hooks. So instead of just you having to compile your native libraries as you're building your package, you can let the user compile them when they're actually building their app, right? So there's this another package written by the Dart team called native toolchain C. And with that, you just define a C builder. So in this case, you can say that you want to compile a library. You include the sort of the C sources that should go into that library. You can also specify optional compiler options, and then you just call .run on that, and that will take care of everything, and that will make sure that the resulting library is going to be available to the Flutter application using them. Another thing that we can use is instead of sort of shipping it as a static asset that we upload to pub.dev, we could say, okay, we will just, I don't know, include the expected hash of the file that we're downloading, and then we will just download it on demand, right? So the target operating system and the target architecture that we're compiling our app for, that's going to be available to, is made available to build hooks, and that will allow us to sort of specify an output directory, and then we can, because this is a regular Dart file, we can use the HTTP package to download the file that we care about and then bundle it with a Flutter app. Maybe, we kind of want to do a mix of the two, and that is also possible because something that we could do is, and this is something I'm actually doing for SQLite, because SQLite is distributed as a sort of source available system where I can just download like the SQLite.c file that is making up the native library in the build hook, and then after I've downloaded it, I'm passing it as an input to the C Builder API, right? And that sort of combines the two steps where I'm able to first download the library and then use that one, which is kind of, it's a system that works incredibly well for SQLite, for instance. Another thing that I can do is I can use libraries from the operating system. So this is sort of the only option I had before, and then I was responsible for actually adding these libraries to the operating system, and this is still possible, right? So instead of saying, please bundle the native library, I can also just say, please expect the library to be available and sort of fall back to the existing approach if that's what users prefer. And another cool system that was completely unavailable in the sort of old style of accessing libraries is that I can let the user decide about sort of which approach they want to take. Because in my build hook, there's this map called user defines, and it's essentially a map from strings to strings. And if a user depends on my library, in their pub spec, they can add a new section called hooks. And then for each of the sort of package they depend on that provides a build hook, they can provide some arbitrary inputs for that, right? And so for instance, they might be able to select a native library or some kind of version of the native library that they want to bind to, and then I don't have to release a new version of my package every time that SQLite updates. I can just tell users to update that single line in their pub spec, for instance. Another thing that they're able to do now, or that was almost impossible to use with Flutter plugins, is that they can perhaps specify custom compiler inputs or custom parameters that they want to pass to the compiler. So for instance, with SQLite, the way it works is that there are lots of optional features, right? So you might compile SQLite with like full text search support or some kind of vector extensions or whatever. And then previously I was the one who sort of had to decide for everyone who's using SQLite with Flutter what kind of extensions they get and what kind of extensions they don't get. And then if a user comes and says, hey, I would really like to use this cool extension for, I don't know, like session support and sort of patching two different databases against each other, I would have to contemplate whether I add that because that for all other users who don't need that feature, they are sort of then paying the tax, right? Because their apps get slightly larger, and it's sort of a tough spot for me to be in. But now that we have this feature, I can just say, okay, I select a sort of default features, which I think are reasonable for everyone. And then if someone wants an additional one, I can just use the user defines option for that, right? And then if someone wants a slightly different SQLite copy, they don't have to redo all the work that I've done previously and sort of fork my package. They can just add a simple option there. So I think that's also a really, really cool feature that is only available once we adopt native assets. So to then perhaps summarize this, I think we've seen a massive improvement, obviously to platform channels, but also compared to Dart FFI, because what we've seen is, I think we can finally take the box at portable, because all of the Dart code that we're shipping at runtime as part of our apps or our libraries, there's like 0 things in there that are in any way platform specific, right? Like we just sort of declare what we are able to do, right? Like we specify which methods we expect to be able to call, and then we just call them. And how that actually works in the end, that's a sort of platform-specific concern that we are pushing to the Dart and Flutter SDKs, and we don't really have to worry about this at all anymore. I would also say that this is finally simple, right? Like you've seen the comparison between the Dart snippet and the C snippet, and it's essentially the exact same code, right? Like there's 0 overhead, at least from a kind of mental perspective, that I now have to use compared to what I would have in a completely native sort of application. So that is why you should all adopt native assets if you care in any way about calling out native functions or like native libraries from your Dart applications. But there is a slight downside, which is compatibility. Because this feature, as I mentioned in the beginning, is still a bit in development. And like you can look up the progress report because it's like a separate project under the sort of Dart language GitHub repositories. So you can sort of see and perhaps expect that this should be done very, very soon, because at least from looking at that kind of progress report, it looks like it's almost done. But at the moment, this is only available on the main channel. So if you use stable Dart or stable Flutter, and you depend on any library that is relying on native assets, you will get this handy warning that, in this case, the SQLite package requires the native assets feature to be enabled, and you need to use this enable experiment flag, right? So obviously, if you care about, stable Flutter apps, enabling an experiment is probably not what you had in mind. So my advice, I think, if you're starting with a new sort of Dart package that will bind to native libraries at this point, I think you can just get started using this new feature and sort of ignore the old style approach, because probably by the time you're done writing the package, or at least that's what I hope, this feature is going to be more readily available. But especially for me, because I'm writing the SQLite package and all these other package authors, there's going to be some transitionary period where we sort of have to support both the old style Flutter libs pattern to make libraries available and the new one for native assets. So I want to show, or just quickly share, an approach that I've done for the SQLite package to sort of facilitate this. And most of the time, when we're writing the Dart code that accesses native libraries, we're not really writing it from scratch, right? Like we're not writing every single line there, since it's all based on a C header file in the beginning that we're sort of porting to Dart. There's actually a handy tool by the Dart team called FFI Gen that automates all of this for us. And FFI Gen supports both approaches. So it supports the old approach where we are calling dynamic library.lookup or dynamic library.open to ensure that the library is available. And it supports the new add native sort of external methods. And there's we essentially have to invoke FFI Gen 2 times, once for the old approach and one for the new approach. And there's a handy feature where we're able to share some definitions which are entirely independent of that. So for instance, if we're defining like a struct in C, it doesn't matter if you're accessing it using native or not, right? Like it's the same structure. And so we can sort of share that between the two. But still, the hook API and the sort of looking up stuff API is very different. And so what I've done for the SQLite package is I'm using a sort of a post-processing step that uses the analyzer package to analyze the interface between the two. And then it sort of merges them together, and it creates like a super interface that is then implemented by both the old style generated code and the new style generated code. And so in SQLite itself, I have 99.9% code reuse between the old approach of binding to SQLite and the new approach, right? So even internally in SQLite, I don't have to care And the sort of public code that users would use is very, very similar as well, right? So I have this previous API. So if you're using the SQLite package today, it's probably going to look something like that, where you just call SQLite and then you could say open in memory to get like a fresh in-memory database. And then afterwards, you can just, I don't know, run any kind of SQL queries against that. And the only compatibility change is that if you want to opt in into native assets today, you add the dependency on SQLite native assets. And then the only sort of interface change is that you're no longer using the SQLite getter, you're using the SQLite native getter. And that's all you had to do to swap out these implementations. And with that, you're able to benefit from all the kind of cool linking mechanisms that come with the native asset system. So to get like a bit of an outlook here, I think FFI and native assets makes native code, not just bearable, but from my side, outright amazing. So I've had the pleasure of not just doing this for Dart, but at work for PowerSync, I had to do something similar for the JavaScript ecosystem, and specifically with React Native and Node plugins. And so Dart FFI, in my mind, is my favorite system that I've ever used to make C functions available, especially with the new native asset system, right? So shout out to the Dart team for adding that feature. That was really great. And a sort of outlook is that we will be able to use the exact same thing, not just for code, but also for data assets. So they're generalizing it into all kinds of assets. And as Flutter developers, you already have like an asset system that is part of Flutter, but you can't really generate these assets on demand, right? Like you can't have Flutter run, I don't know, transparently convert a PNG into like different sizes and sort of attach it to your app. And with the sort of upcoming data asset system, that is something that you would just be able to do. And then, of course, it would also work on all platforms. So if you're trying to include data assets to a Dart application server, like something that runs in your backend, that is something that you would be able to do. And today it requires some external tools, which are probably quite hard to use. So that's it for my talk. I've added like a little QR code here and a link, and that contains some helpful pointers to some of the build hook definitions that I've shared in this talk. So you're welcome to check those out anytime you like. And I think if there are any questions, I still have a few minutes. If any of you has like any questions about binding to native code from Dart. Yeah, sure. I think there's a microphone over there.
Hello, my name is Jacob. Great talk, thank you. So one thing we're doing right now is using Android app bundles to separate language resources. And we have to essentially use plugins to ask Android which resource file to load, and then do that there so that we don't package all of our languages resources by adding them as Flutter assets. Is this something like FFI could do or replace that sort of system?
So with the existing FFI system, what I know that I'm doing for SQLite today is, well, if you're using like with the old style system, you have like an NDK block in your build.gradle, right? And that adds like, either with CMake or with the Android NDK build system, you define the sort of libraries that you want to link. And then if you generate an app bundle from Flutter using that, the Play Store is able to recognize that. I don't know if you're running on an ARM device, you get like a specific APK that doesn't contain the native code for an x64 device, right? So that's something that already works with the old approach, and I would expect this to just continue to work with the new approach, right? So I assume that if you're running like Flutter build app bundle, it should generate something where it contains it for all the different APIs, but your users are only paying for what they really need.
Thanks.
All right then. So thank you for attending my talk.